Welcome to Analytik Jena's video tutorial series on elemental analysis of edible oils and fats by ICP-OES. You're watching the third episode on measurement and data evaluation. Make sure to check out the other episodes as well on our Analytik Jena YouTube channel.
Let's start the measurement. As soon as the measurement of the standards is finished, we should check if the calibration of the method was successful. Important measures are the correlation coefficient and the deviation of the nominal values of the standards in comparison to the measured values. Reasons for a failed calibration may be wrong fitting, non-optimized method settings, or insufficient preparation of the calibration solutions. Regarding method settings, the correct choice of the plasma observation mode and the correct choice of the emission line is important, because the signal of the higher calibration standards may run into saturation and the sensitivity for the lower concentrated samples may not be sufficient for a precise calibration measurement. The use of internal standards is recommended for more complex sample types, since they can detect and correct for drift effects. Internal standards also provide an information if the sample dilutions match the calibration strategy. In ICP-OES, argon is often used as internal standard element, since it can correct for plasma-based fluctuations. Elements that are present in the measurement solutions are able to detect sample transportation-related effects. Typical elements used here are either yttrium or cobalt. The internal standard recovery can deviate from its ideal value of 1, which then indicates several issues. Certain deviations in internal standard recovery are acceptable since they can be corrected accordingly. The tolerable limits are often set by each laboratory itself. Another cause of decreasing sample amount in the plasma and hence low internal standard recoveries can be a gradual suiting of the injector. Therefore, we recommend to apply countermeasures such as the optimization of the torch position or the addition of oxygen in the plasma. A very common source of errors are leakages in the sample introduction system, originating from worn tubing, loose connectors, or back pressure in the system. Therefore, it's recommended to inspect and change the pump tubing material on a regular basis. Back pressure in the system can occur if the nebulizer is clogged or if an insufficiently small nebulizer is used. If this error occurs frequently, change the nebulizer type or adapt the pump rate and the nebulizer gas flow. Another control criteria regarding the accuracy of the results is the recovery of quality control standards. Those can be certified reference materials or spiked samples. The comparison of these measurement results with the certified and nominal values represents a permanent quality control of the applied method. If you have a poor recovery of your QC samples, check the method settings, the used consumables, and the used chemicals. The following reasons can result in poor QC recoveries: carryover effects from previous samples or calibration solutions, insufficiently long take-up time of the measurement solutions, or contamination of the measurement solutions from chemicals, vials, or sample tubing. If QC samples are in general not passed, it is advised to review the method settings and the sample preparation procedure. In our measurement, all quality criteria are met and we have successfully finished the measurement.